Good morning, Year 12. Thank you for joining me. Welcome back to your next and final lesson in the stats topic. Before we get started, here is a quick revision question from the 2012 HSC paper. If you could pause the video and figure out if it's A, B, C, or D, that'd be good. Okay, hopefully you did that and you got the correct answer of B, 1/3 ln 4. If you didn't get that and you're not sure why, here is a quick solution. Just taking the 1/3 out the front and integrating 1 on x as ln x, applying your limits, and don't forget that ln of 1 is just 0 because e to the power of 0 is 1. All right, so today we are going to be looking at comparing data sets. So we're going to tie together all the ideas we've looked at so far and sort of make some calculations, make some judgment calls, and compare two data sets and see what we can say about them. So this stuff does take a bit of independent thought, which is a bit challenging in a stats topic, but we'll see how we go. All right, so the first thing we'll be looking at is the modality and skewness of a distribution. So when we're talking about modality, this refers to the word mode, which as we looked at refers to the most common score. So if we're looking at a distribution like this data set here, we could describe this data set, this distribution, as unimodal, okay? Because the graph only has one peak, so there's only one true mode for this data set, okay? If we had a histogram that had two peaks, like this one here, we could describe this as bimodal, okay? It's got two peaks, even though this one here is slightly lower than this one. So in terms of the overall mode of the data set, this is the mode. But in terms of describing the shape, because there are two peaks, we'll describe this as bimodal. Okay, so a mode doesn't have to be the most common score. It could be a score that is more common than those around it. So it's kind of like a relative maximum, whereas this one here is a global maximum, kind of like in calculus. Okay, and here's one that could be described as multimodal. Again, same concept. While there is one true mode here, we will refer to these peaks as sort of modal scores. Okay, so relative maximums are modes. So this is a multimodal distribution or data set. Okay. Now, if we're talking about skewness, first thing we need to look at is symmetry. Okay, so if you have a data set which is symmetric, it means that your average, your mean, and your middle, which is your median, are both in the same place. Okay, if you have the mean, the median, and the mode all equal to the same thing, it could look like this, which is referred to as the normal distribution, commonly referred to as the bell curve. Okay, so for a symmetric data set, the mean and the median are very similar or the exact same. If we had a data set that was a bit asymmetric, where suddenly we have more scores to the right of the mean, so more higher scores, we call this a skewed data set. Okay, the median and the mean are not in the same place, so there is some skewness. And we call this one positive skew because it is skewed towards the larger numbers. If we were skewed towards the smaller numbers, it would be called negatively skewed. So it's similar logic to a number line. Negative is on the left, positive is on the right. It's the same thing with these tails, okay? There's a skew going towards the negative end, so it's negative skew. Here, our skew is going to the positive end. That's how it makes sense to me. So if you're asked to describe a data set, you can talk about whether it's symmetric or if there's a skew, and you can say whether it is positively or negatively skewed. All right, so since we are talking about sort of analyzing graphs and data sets today, it's probably a good time to have a quick chat about ways that you can be aware of misleading graphs out in the real world. Okay, so these are really common of people trying to sort of deceive you by not giving you the whole picture or sort of giving you a sort of narrow view using statistics. So here's just a very simple example to start. So here, the creator of the graph is trying to show that from 2000 to 2001, home sales have doubled, okay? Because suddenly we've gone from this height to this height, so we've doubled. But of course, our brain does not perceive this as doubling because we can see the area of the shape has, tripled, maybe quadrupled. So this is a bad scale because even though the height is doubling, the way we perceive it has not doubled. We are perceiving this as more than a doubling. So this would be a misleading graph. You need to use better scaling. Here's another similar one. This is what's called a truncated graph. So by truncated, I mean that the y-axis does not start at 0. Okay, a vertical axis only goes from 9100 to 9800. And so what you're seeing from these 5 distinct groups is what appears like quite a significant difference. Okay, until you make this scale a bit more fair, and instead of starting at an arbitrary number, if we start it from 0, it suddenly looks like this. Okay, so if we untruncate it to make the y-axis starting at 0, suddenly these massive differences are not so massive. So you have to be aware, okay? When you see column graphs, first thing you should look at is the axes to see if they've been labeled fairly or correctly, because how you label these axes and how far zoomed in you go can clearly change what the graph is trying to say, essentially. So be mindful. Fox News in America is absolutely rife with these all the time. Again, kind of like what we just said, here's a column graph. We have 6 million is this bar here, and roughly 7 million is this bar here. So this graph is trying to show that Obamacare was a massive failure. Obviously, the true failure is this graph because they had to eventually reprint it or rebroadcast it with an appropriate axes for the vertical axis anyway. And suddenly this massive failure, this massive difference, when you graph it fairly, becomes pretty regular, okay, pretty close to the target. So yeah, if you Google Fox News misleading graphs, you'll see heaps of these. Here's another one. So this is the average cost of gas. The y-axis is the price, and the x-axis is time. So what they're trying to show is that we had this massive spike in, or massive increase, and then it suddenly started flattening off. So you might read this and think, oh, the cost of gas is flattening off. But if you look at the x-axis, this is last year and this is last week. So this gap here is 1 year, and this gap here is from last week to current. This is a 1 week gap here. So what they've done here is they've made the x-axis very inconsistent, where this gap here is a year and this gap here is a week. So of course it's going to flatten off. Okay, so because they've dodged up their x-axes, they've sort of made the graph show what they want to show, which is very bad. And here's one last one. This one's pretty tricky. We have across the x-axis is time. So these are years from 1964 to 2010. We have the red line showing the average income of a bachelor's degree, and the blue line is the average cost of a 4-year degree. So that's tuition, room, and board. Okay. What this graph is trying to say is that, well, hang on, you're still earning the same amount for a bachelor's degree, but it's costing more and more to go to university. So is this worthwhile? Is $95,000 worth $45,000? Okay, which kind of seems like a fair graph until you think about it a little bit more, because this is a figure over 4 years. Okay, $95,000 over 4 years is a lot of money, whereas with the red line, you're earning $45,000, but you're earning that per year. Okay, so this figure here is just a one-off 4-year payment, and then this red line is what you're going to earn for what, 40 years? So it's not really fair to compare these two and saying that, oh, well, this one is so much bigger than this one, it's not good value for money. Well, it is, because you're going to continue earning money for the rest of your life thanks to your bachelor's degree. So yeah, sometimes you have to just make sure, have a think about what the graph is trying to say and decide yourself whether it's fair. All right, I could bang on about weird graphs all day, but
I ain't spending any time on it, because in the meantime, every 3 months, a person is torn to pieces by a crocodile in North Queensland.
All right, so moving on. Here is our first example. We have 2 surveys conducted asking students how many Zoom meetings they attended in the last fortnight. Compare the shape and spread of these data sets. So we've got 2 box plots. Here's the first survey, here's the second. I want you to have a think about the differences between these 2 data sets, and then we're going to have a chat afterwards. All right, so some things we can think about based on our box plots. So box plots give you a really good idea of shape, but it's hard to tell things like, well, you can't calculate the mean because you don't actually know what the scores are. You just know where they are. You can't calculate standard deviation. So what we can figure out is the range. So we can see clearly that the range on survey 1 is going from 0 to 7. That's a range of 7. Whereas survey 2 is much more consistent. It's only spread over 4 scores. Okay. Keep in mind that with survey 1, you might be asking, well, where's the lower whisker? Well, it's just that the lowest score and the lower quartile are on the same spot. So it's got a very concentrated sort of low end on the 0. Okay, so a quarter of this data set at least is 0. So no Zoom meetings. We can look at the interquartile range. So for survey 1, it's the width of the box, which is from 0 to 3, so 3. And for survey 2, it's only 2 units, So we have two scores, I suppose. And then for skewness, well, we can see that survey 2 is very symmetric because every quarter is going over one score. But for survey 1, the median is at 2, and then the top end is at 7, and the bottom end is at 0. So this top half is being stretched really far. And so if you think about what this would look like as like a histogram, we'd have like a bunch here and then a tail going towards the bigger numbers. Okay, so whichever way the tail points tells you what type of skew you have. So because we're going towards the positive end, we're going to have positive skew. Okay, so if we wanted to compare the shape of these two data sets, we could say that survey 2 is very symmetric, whereas survey 1 has positive skew. If we want to compare the spread, we can say that data set 1 is far more spread out, and here is our proof, whereas survey 2 is much more consistent and sort of clustered. So something along those lines. So here's just a sort of quick diagram showing you what a skewed box plot looks like. As I said, it's more of a spread towards one end, or yeah, it's just more of a reach towards one direction. So there's a sample answer for you guys if you're not sure what to write yourselves. And from this, we can pretty safely assume that these two surveys were not taken from the same population because the data is so different, okay? And when I say population, I don't mean like same country population. It could be different year groups, it could be different schools, it could be different regions. So this one here could be a rural region, so there's more spread, whereas this one could be a city region. It's hard to say. All right, for our next one, we have the results from a take-home exam recorded for 2 different classes. So we have a science take-home exam results here and an English take-home exam results right here. Compare the data sets in terms of mean, spread, and shape, and imagine there is a full stop right there. Okay, so what I want you guys to do is practicing what we were looking at last week with our calculators. I want you to calculate for the science data set the mean, the standard deviation, the median, and the range. Okay, so for these first two, I want you to enter the data into your calculator in stats mode, compute these two values. You can compute the median if you want, or you can just count it in. Either way is pretty easy. And the range you can just get from inspection. Okay, so practice getting your calculator in stats mode, find these 4 values for me, and pause the video until you've got those because I'm going to spoil them for you. Okay, so here are our answers for science, assuming I entered it correctly. Hope I did, otherwise this is on YouTube forever. So when I entered it in, I got a mean of 69.8, shout out to Ethan, and I got a standard deviation of 12.77. Median is 70 because the two middle scores were 68 and 72, so a middle of 70, and a range from 50 to 94 is 44 numbers. Okay. Now I want you to turn your calculator off and on again to clear the data, put it back into stats mode, enter in the English scores, and there's less of those, so it'll take you less time. And again, compute these 4 values so we have some ammunition to compare the two and make accurate assumptions or predictions, I suppose. Okay, hopefully you paused the video and did that. Here are the answers, assuming I did them correctly. So we got a mean of 68.8, we got a standard deviation, and remember it's the population one unless specified otherwise. So we got 13.42, median of 63.5 because it was between 62 and 65, and a range of 54 from 43 to 97. Okay, so now we look at these two and we compare them. So if we're comparing the average score, the mean, well, they're both pretty similar, okay? They're both around 68, 69, 70. So the average mark for both courses was pretty consistent, although science was slightly higher, just by like 1 or 2. Okay, so now we talk about our spread. So over here, we have a standard deviation of 12.77. Here we have 13.42. And if you remember from last lesson, I said that standard deviation measures spread. So a higher standard deviation means a more spread out data set. Okay, likewise with the range, we've got 44 here and 54 here. So that is enough evidence for us to say that this data set is more spread out than the science data set. All right, now let's talk about, we can talk about skewness. So first of all, for science, we have an average, or a mean, sorry, of pretty much 70, and median is 70 as well. So when the mean and the median are very, very similar, or the exact same, that's another way of saying, well, this data set is symmetric, which you can see. It kind of looks like a bell curve. Okay. Whereas with the English scores, the median is 63.5. That's the exact middle. But the average, the mean, is 68.8. That's like, what, 5 scores bigger? So when your mean is above your median, that tells you are skewed towards the bigger numbers, aka positively skewed. Okay, so if we want to compare the shape of these two, we can say with proof that science is a symmetric data set, whereas English is a positively skewed data set. Okay, so science symmetric, English positively skewed. Okay, so that's really all we can say for this. I guess we could find interquartile range if we wanted to, but we already have 2 measures of spread, so that'd be heaps. There's not really any significant modes, so I think that'll do it. That's all they're really looking for in this question, just comparing the centers, comparing the spread, and making a judgment call, or not a judgment call, a call with proof as to whether this one is symmetric or skewed. Okay? Hopefully that makes sense, and you can practice yourself in exercises 907, 908. Just get a variety done, and you'll be sweet. All right, so thanks very much for watching, and I'll see you guys later.